Hello and welcome to Week 3's lecture. Week 3's lecture is entitled Quantitative Research, and as the name suggests, we're going to start to look at how to do quantitative research. We'll start by looking at how not to report quantitative data. So have a good look at this table. Have a good long look at it. I'm looking at it as well. Do just pause the recording and have a good look. The first thing I can see is there's absolutely no heading. I can't see what this is supposed to be telling us. What is it about? And then I can see that there is some kind of legend for each of the two tables. So there are two tables side by side. And it says total number of tea sold in GBP. Well, there are two problems here. I need a glossary for GBP somewhere. I can't assume that people know it means pound sterling. It might be better to use the pound sign. But I can't actually see what it means. I mean, what does it mean? Cups of tea? Does it mean millions of tons of tea? So it's a pretty badly prepared legend. And I can see then that there is some kind of reporting going on which would suggest that there are millions of units. So in China, I can see in the left-hand top column, I can see China 1.378,0. I'm a little bit confused because we seem here to have 1.3 used as a decimal point for millions and then a comma. Why a decimal point and then a comma? What exactly is the unit that we're reporting in? And then the table below says per capita, so I assume per head of person. But again, I'm none the wiser. And I can see that I'm clearly supposed to take something from this. It looks like China buys more tea, but actually per person, the Chinese drink less tea per person. And that's presumably because they're a larger country. I'm supposed to infer some sort of relationship from this, but I hope you can agree with me that this is so badly presented and so badly explained that I'm not really sure what I'm supposed to be extrapolating from these two tables. I'm clearly supposed to be comparing them and coming to some sort of conclusion about the patterns that are found there, but I can't really find the patterns because the legend is so poor and because the reporting of the numbers is so poor. So hopefully we've had a look at how not to report quantitative data. So then, we might say which bits of research design are generic, which bits can be used for quantitative research design as well. And I think we could all agree that a well-formulated research question is necessary for quantitative research. We must have a research question, we were talking about this last week, which attacks a particular problem that we wish to solve. And if it so happens that we're going to solve this through collecting quantitative data and analysing quantitative data, well, good. And we're also going to report our findings. We've just seen that there are very bad ways to report those, and there will be better ways. I hope to scaffold and show you much better ways to do this. But in fact, the slide that I showed you encapsulates many of the problems that even experienced researchers have. They take too much for granted. They assume that people know what per capita means. Don't assume that everybody has Latin. They assume that people know what GBP means, so don't assume that people know what abbreviations mean. They don't specify the units that they are collecting. They don't explain the graphs well enough. And thus, many of the findings that they have are actually lost in the telling of the tale when they present their data. What's different about quantitative design then? Well, quantitative design and the research surrounding quantitative design tends to have a hypothesis or hypotheses. Okay, we tend to make a hypothesis about a particular situation, and in fact in the hard sciences the tendency is to make a null hypothesis. That is not to predict either direction in which a change might be happening. So not to say that a change is happening, not to say that a change isn't happening particularly, but to state a null hypothesis. We'll come back to that. It's also based in theory, so it does share this again with qualitative design, but it might be based on a perhaps more well-articulated theory. So because qualitative data, as we will see in the weeks to come, is harder to pin down, sometimes covers the psychosocial domain, so how we're thinking about things, what we talk about, and what we actually mean when we're talking about things. So for example, discussion of politics might come under the qualitative section, whereas voting intentions could be turned into quantitative data. Okay, so but I can just say, we'll assign a score of, so assign a letter A to anybody intending to vote for the Labour Party, assign a letter B for anybody intending to vote for the Conservatives, C for the Liberal Democrats, ad infinitum until I've coded everybody in an exit poll, and then I can say something quantitative about voting intentions. Quantitative design needs to think about operationalization. So it needs to think about how we're going to put hypotheses into action, how we're going to test hypotheses through the methods that we use. We also pay a lot of attention, though so do qualitative analysts, I have to say, we pay a lot of attention to the sampling framework. So we pay a lot of attention to how we build the framework of who we are going to ask and what we're going to ask them. So if we're looking at a question like, for example, drinking alcohol in pubs and increasing religion are correlated with each other. Okay, so we want to suggest in some way that perhaps more and more people being religious is leading to a decline in alcohol drinking. How are we going to do that? Who are we going to ask about their drinking habits? We can't just ask people who drink in pubs because we want to know about who isn't drinking in the pubs as well. Should we include children? Probably not, since they're unlikely to be found in UK pubs. They're unlikely to be drinking alcohol because that's illegal. Should we include very elderly people? Yes, probably. Why not? You don't stop drinking when you get older, or you don't suddenly start drinking when you get older. There's no reason to suggest from the literature that that might be so. So we need to think about who we're asking, where we're asking them. We need to think about how many pubs we can go to. We need to think about where we're going to source the people who don't drink. Will they be harder to find? Will they be harder to ask? And what will we ask them? Collecting the data then. We need to think about how to collect the data. How will we collect quantitative data? We could ring up a chain of public houses and ask them for their sales figures for the last 10 years. But how would we prove from a decline in sales figures that the causal factor for that is more people finding religion? We are going to actually have to ring up lots of churches, lots of gurdwaras, lots of temples, lots of mosques and ask for their attendance figures. Have they risen? Can we see that a rise in evangelical Christianity or Methodism is contributing to a decline in the hospitality industry? So we're going to need to think about the kinds of data that we collect. Then we're going to need to think about how to analyse that data. So we've got sales figures, we've got attendance figures, we can correlate those in a particular location, but again we can say nothing about causality. So there may be a limit to what quantitative research can tell us about the hospitality industry and the effects of organised religion on the hospitality industry. We need to think about perhaps soft drink units. Have they also risen? If soft drink units are rising, can we say that that's anything to do with organised religion, or is that perhaps to do with pubs becoming more child-friendly spaces? Is it perhaps the case that sustained public health campaigns have something to do with this? Should we look at public health funding, look at the amount of millions that have been put into be careful what you drink, responsible drinking campaigns? Have they also contributed to a decline in alcohol units being sold? Is alcohol being consumed elsewhere? Should we look at police reports of illegal stills, illegal vodka stills? Should we look at supermarket reports for the sale of alcohol? We need to think about all of these things, and we need to think about, again, which hypotheses we are testing. Do we still want to test the hypothesis alcohol decline correlates with the rise in organised religion in the UK? Do we want to test that hypothesis, or are we now looking at a different hypothesis? Supermarket prices contribute to the, correlate with a decline in pub sales. Okay, so that is quantitative design. And in this sense, it shares many of the elements that qualitative design will share, but we will see that there are differences as we unpack qualitative design in weeks 6 and 7. And indeed, I can show you now, qualitative research design tends to be more circular, more reflective perhaps than quantitative research design. And there is indeed an argument that quantitative researchers could learn a little bit from qualitative researchers. So qualitative researchers, not unlike quantitative researchers, I have to say, if you look to the left of this diagram, they come to things with pre-assumptions, but they should try and put those pre-assumptions on hold. They might do a first case study where they collect data and analyse it. They might then sample a second case study, collecting data and analysing it, and compare the two. Having done that, they might move on to a third case study of collection and analysis. And having completed those 3 things, they might then compare in a circular way all 3 of these different cases. So a qualitative researcher might, for example, conduct a focus group with people who shop at a supermarket and get their alcohol there. Perhaps they might find people who've brought little pop-up pubs during lockdown, little wooden pubs that you can put up in your garden. They might also interview people who have signed the pledge, so who have decided not to drink alcohol anymore, although sourcing those people might be tricky. And the first case study might be a group of drinkers from a pub. The second might be a group of drinkers who shop in a supermarket, and the third might be people who are teetotal for religious or other reasons. And then they will compare all of these and form new theories. So qualitative research tends to be more reflective and more circular. You go round and you reflect and you look at groups that you have looked at before, and it's a slower process. So often quantitative research seeks to tell us something definitively through looking at large data sets numerically, making statistical predictions, where qualitative data teases out perhaps the contradictions in that data set. Perhaps it says awkward things like, well, if organized religion is on the rise, why do so many people say that they simply, they don't believe in God anymore? It's true perhaps that Islam is growing. It's true perhaps that the evangelical Christians are rising in the UK. The number is rising. But actually, Judaism is declining, so is Sikhism, and we might want to ask why that is. So they might tease out explanations like that. They might say, for example, we really do need to investigate supermarkets and the role that they play, because they often have bog-off offers where you buy a bottle of beer and you get one free, or you buy some flowers and you get some champagne free for Valentine's Day. We might want to look at supermarkets like Marks and Spencer's that do meals for you and then provide free alcohol. Are they replacing public houses? So they tease out some of the more invisible connections, and they do this by reflecting and looking back and looking forwards. Different designs, though, they do have stages in common. So even if we're doing quantitative research, we should have a planning stage where we state our questions and our hypotheses. We were talking about this. We had some hypotheses about the relationship between organised religion and alcohol consumption. And we identified the variables. So the variables in our case were people who drink, people who don't drink, the price of alcohol. That might determine our design structure, and indeed it did begin to determine the design structure, because we began to see that we would have to gather data from people. So we began to see that there would probably need to be 3 rounds of questionnaires given out in a quantitative survey, that we would have to ring supermarkets up and say, here is a questionnaire, or can you send the sales figures for last year? Dear churches, please can you send your attendance figures for the last 10 years? And this might even be hard to get hold of, so we then have to rethink it and see if we can get this data by proxy from perhaps, we would have to ring up the diocesan office. So if we're in Coventry, we'd have to ring up Coventry Diocese and ask if they hold these figures for churchgoers. We're identifying populations, and we're going to think about this more and more. And as we go along, as we do these reflections on Moodle with each other, we can really start to identify populations. And in fact, populations, you might think you've identified them, but then you might think, well, what about this particular religion that I hadn't thought about? I've just completely forgotten about them. What about them? Do they drink? I don't know. Let's ask, let's research. And we're going to have to identify a sample. We can only sample a given number. So who do we sample? And this will matter. If we're talking about organised religion and alcohol consumption, Methodists traditionally didn't drink. But there's nothing to say in the Catholic Church that you should give up alcohol. And indeed, there's nothing to say in Church of England doctrine that you should give up alcohol. So it matters who we're talking to. We're going to have to design instruments then, and we're going to classify, aren't we? We're going to have operational definitions. So we're going to say, do I talk about Christianity, or should I separate out Methodist Christians from evangelical Christians? Do I talk about supermarkets, or should I separate corner shops out from that? We're going to have to design instruments, and that will probably be questionnaires, or questionnaires to elicit sales figures and attendance figures at places of worship. Then I'm going to have to select statistical tests for resolving hypotheses. That is, appropriate tests for the amount of data and the kind of data that I've collected. And that is definitely something we'll be coming on to in the next week. And then we have what we call the execution stage, ominously. So we do carry out, and we plan, and we collect data. And we may find that things go wrong in that data collection session, and we will have to report on that in our findings. It may even affect the findings as we have them. So we might find that within our time frame, for example, the Diocese of Coventry doesn't reply to us, but maybe the Diocese of Birmingham does, and we'll have to use proxy figures from a neighbouring city. Will that matter? It's a much larger city than Coventry. We're going to have to think about how much data we've collected, whether it was appropriate data, whether it's even appropriate to run statistical tests. We're going to then analyse that data, draw what conclusions we can, but not overdraw conclusions, not underdraw. So we need to thoroughly investigate all the data that we can, draw our conclusions, and evaluate the process. So there will be two distinct stages, that is planning and execution, and they shouldn't, in theory, overlap. Okay, so we shouldn't have to go back down and re-identify the population and the sample. That's evidence of quite poor planning. We don't want that to happen. We want the planning stage to go smoothly so that the execution stage can proceed as smoothly as possible. Unforeseen hurdles accepted. So we can have different designs for our research sample and our method. If we have a pre-experimental sample, we don't have a control group. And indeed, it's hard to think of a control group when it comes to drinkers versus non-drinkers. Who would that be? Who would our control group be? There isn't any particular control group. We're looking at not laboratory conditions, so we're not working in experimental conditions. If we were, we would set up some kind of experiment with churchgoers and non-churchgoers, and we would give them the option of going to a pub or supermarket, and we would see what drinks they purchased. That kind of thing would be laboratory conditions, and we would have to do it not in the real world, but in some kind of laboratory where we set up a fake supermarket and a fake public house and a fake room for private worship, and we would have to observe behavioural conditions. Well, that's not what we're talking about in the scenario that I've dreamt up for the purposes of this lecture. So, then we will be looking at things like dependent variables and independent variables, and we would be talking about those, and we'll come back to that later on. Okay, we can manipulate the various variables. So if we're talking about independent variables, they can be controlled and manipulated, and we'll come back to that. I'm going to put a discussion about that onto Moodle. If we have a quasi-experimental situation, then we have a non-equivalent control group. So that means something like, just think of an example. For example, if we're talking about the scenario that I've concocted about looking at drinking habits and organised religion, then the control group that we invite to our laboratory would be a group of people that we already know. Now, this is problematic because we haven't selected them at random, so we can't control for factors like whether they're telling us the truth, whether they are more likely to be honest about their drinking habits, whether they are likely to behave in a natural way. So this is problematic. Okay. You will come across the term ex post facto, which is where the independent variable, like drinking habits, is observed but not manipulated. So we don't seek to influence behaviour. We would simply allow people to wander between rooms. We wouldn't seek to manipulate their behaviour. And we've come across the term correlational. A correlational design seeks to uncover a relationship between variables without reference to causality. So we might observe people going into our pub room and drinking a pint of beer, but that might not be connected to. So we might find perhaps that some people going to church are drinking. Some people who don't go to church are going in there and having a drink. Some people who normally don't drink go and have a drink. But we don't seek to make any causal relationships. So that wouldn't actually be appropriate for the research project that I've designed, that I've been talking you through. That wouldn't at all be suitable. It's hard, really, to imagine me doing my drinking experiment. It's not a way to answer the question about a drinking habits experiment. That's not really something that could be well targeted with qualitative methods. So qualitative methods is for much smaller scale, in fact, much finer detailed projects in many ways. We can have a large number of people passing through, but the scenario is greatly controlled and restricted by the researcher, which can lead to problems when we extrapolate to behavioural patterns in the real world, which is why medical trials often do lead to issues. When we follow people and we observe their behaviour in laboratory conditions, we cannot be certain that they will replicate that outside the laboratory. Again, how do we get in a quantitative situation from a research question, so a broader identification of a problem, to a hypothesis? Well, a hypothesis should be based on some kind of accepted theory. So if we think about gravity now, nobody's going to posit things about gravity that aren't already based on what we know about gravity in our solar system. Nobody's going to posit things about gravitational force that aren't already based on our knowledge of gravity and how it acts on our solar system. And the hypothesis might be based on specifying some relationship among variables. So if I say, for example, working class people are more likely to H-drop. Okay, so working class people, to define who working class people are more likely to H-drop. I haven't said when, I just mean generally, so we'd have to think about that. That's a research question, and my hypothesis might have to be a bit more targeted. So I might have to say something like, UK working class people in Coventry are more likely to H drop if the social situation is more relaxed. Okay, that would be a hypothesis. And a limited number of variables are included. So you can see there I introduced the independent variable of class and the dependent variable of situation. Okay, so whether we are in a relaxed situation or a formal situation. You can see how I might test those things. I might test the formal situation by getting them to attend a mock interview with me. I might test the informal situation by observing them talking in dyads behind a screen. So I could get them to talk to a friend behind a screen without me involved. But the important thing is that I can measure these. I can classify these different variables. So I can classify class. I can ask them, for example, what level of education they attained, perhaps whereabouts in Coventry they live, what they do for a living. I can classify H dropping because I can classify is the h present or not in the word at and ought. I can classify the stylistic situation because I can say F for the formal environment and I for the informal environment. And thus I can place numbers on those values and they become potentially valid definitions of concepts. Okay. The direction of potential causality is not questionable. Well, if I want to say being working class causes people to drop H, that is a directional causality that I am implying in my hypothesis, and I might want to think about whether I want to do that. I could leave it at a null hypothesis and say there is a relationship between social class and H dropping in Coventry. That is a null hypothesis, okay? That's not going one way or the other. It's not a directional hypothesis. Representativeness of the conditions in which the study will be conducted and the sample are achievable. Now, what I need to do is make sure that I interview enough people in the city of Coventry to be able to say something about working class people across the city of Coventry as a whole. And already I hope you can hear alarm bells ringing. This is the problem with quantitative research. How many people do we need to interview and in what circumstances for something to be representative, for the sample to be representative? And I will be teaching you in the readings that we're doing about the kinds of numbers we need and the kinds of instances of H dropping we need to make us sure that our sample is representative and that the data we have gathered are enough. So we will be talking about how much data is too much, how much data is enough, how many informants are too many, how many informants are enough. And it will obviously have to do with the population of Coventry. We're going to have to look at census statistics. We're going to have to look at how many people go down on the census in the city of Coventry as being of working class status. Okay. We have to make sure that any treatment that we think of could be designed to be sufficiently natural as to allow extrapolation of results to the relevant real-world situation. So if we're going to my scenario where I said that I would let people talk in relaxed dyads, two people who know each other, and I would then interview them, we need to start thinking. We need to really start thinking about whether my laboratory-based treatment is natural enough. Is this natural? And as linguists, we're going to have a lot to say about this. We're going to have a lot to say about laboratory-based conditions and whether they can be replicated in the real world, and whether we might actually want to do some qualitative work alongside our quantitative work to see whether the same things really do happen when people are outside the laboratory in a sort of so-called real world situation. It's all the real world, but a laboratory, I hope you agree with me, is very often not reflective of how we spend our everyday lives, and so we need to be careful. Now, by implication, the timescale over which the study will be conducted shouldn't introduce other variables. So, for example, we need to think about conducting a study on H dropping with adolescents, because adolescents, the research shows us, if we do our literature review, that adolescents are acquiring their social norms. So if you ask young children in working class families, they are often blissfully unaware that H carries any kind of social stigma at all in the wider community, and they will H drop without hesitation. As we mature, so as social linguistic maturation takes place, we may become aware that in England H dropping is stigmatised, and we may stop doing it. So we wouldn't want to carry this out over 20 years unless there were a very good reason, unless we were overtly studying social linguistic maturation as one of the variables. Okay, we don't want to be doing that. So we need to do this over a period of time in which other influences can't come into play. Have a look then. What have we got here? Have we got a research question, a hypothesis, or a null hypothesis? There is a positive relationship between the number of books and articles read and the final marks on the trial assignment. Okay, well, because it's a statement and not a question, we can rule out the idea that it's a research question. The question is it a hypothesis or is it a null hypothesis? Okay, and the answer is that a null hypothesis doesn't have a directionality. If we can see some kind of directionality in the statement, then it's a hypothesis. And in fact, we find that this is a hypothesis that proposes a positive causal relationship. There is a positive relationship between the number of books and articles read and the final marks on the assignment. That is, the more books you read, there's some sort of relationship between that and the marks that we achieve at assignment. And it don't say whether the marks get higher, but the positive tells us that. There's a positive relationship. The more books, the higher the mark. That is a hypothesis. Now, research question, null hypothesis, hypothesis. Has the number of sunny days each year in a country a significant positive relationship on the number of kids born in this country each year? So if we have more sunny days, will there be more children born? Well, that's a question. So it's just a research question. It happens to have some kind of causality implied, but it's not set out as a hypothesis. It's not set out as a statement. So it's a research question. How does studying abroad affect the development of intercultural competence? Well, this is a very, very broad question. It's a research question in its initial stages, I hope you can see. And it's a question, so we can tell straight off that it isn't a hypothesis. Same thing again, we've got a question mark at the end. Is there a relationship between social class, education and the intercultural competence of 18 to 24-year-old British students? Well, I want you to think about this as well. How would we bring this from a research question to a hypothesis? Because it is a research question. And it's a pretty densely packed and complex research question. It proposes to examine the interplay between 3 different factors, one of which is notoriously hard to pin down. What is intercultural competence? How would we even go about measuring that? How would we go about measuring something as complex as intercultural competence and assigning ratings to participants for their intercultural competence? Social class is hard enough to measure, you will find when you come to measure it. Education levels are relatively simple, although they're not always that easy to compare. But this is a pretty complex research question in its infancy, actually. Okay, what about this one? There is no significant relationship between the sex of a person and the number of handbags bought each year. Well, it's clearly some sort of hypothesis. The difference here is that you can see this is a null hypothesis, and it plays, if you like, devil's advocate with the researcher's beliefs. So instead of stating a belief that there is a positive or negative relationship between 2 variables, it posits that there is no relationship. This is a null hypothesis, and this is absolutely the norm in the hard sciences, that one posits a null relationship. And the hard sciences seek to disprove their own hypotheses, so you're more than welcome to do this. That if we have no idea, we posit that there is no significant relationship between the sex of a person and the number of handbags bought each year. Okay, so we're positing it doesn't matter if you're male or female, you're just as likely to be buying a handbag. So I'm not sure that anybody would actually believe that, but you posit it as if you didn't believe it and you test it. So this is a null hypothesis. If you see the word no significant relationship, it's a null hypothesis. So, that was a fairly short lecture for this week, but there's much, much more to be doing on Moodle. So make sure that you do listen to this lecture again, take notes because we've gone through an awful lot of terminology. Read this chapter, read also the chapters that are recommended for this week, and look on Moodle where you will find more activities that I will be taking part in with you before the seminar. And it's absolutely essential that you do take part in them and that you do what you're asked to do before we meet in the seminar. Thanks.